standard 9, we'll continue to do some work in logarithms. I have written a few questions. I'll be doing a few more questions based on logs. It is very important and necessary for you to understand. Like I told you, log is a very important tool in mathematics and we must be well versed with it. For example, look at question number 1 where it says 3 log under root n plus 2 log n cube root 3 minus 1 is equal to 0. He says find m to the power 9 n to the power 4. Let's write it down here. 3 log under root m plus 2 log cube root of 9 of n minus 1 is equal to 0. Now in place of minus 1 I'll write log 10 because there is no base written here. That means I'm assuming it's a common logarithm. So I'll write log 10 to the base 10 will be 1. It can be written as log m to the power half into 3. This power can go up. We told you in the power law. This power can go up. It is m under root means m to the power half and this 3 will go up, so into 3. Similarly here plus log n to the power 1 upon 3 and 2 will go up from here is equal to log 10. Log 10 is 1. I have written log 10 is 1. Now it will become what? Log n to the power 3 upon 2 plus log n to the power 2 upon 3 is equal to log of 10. Log a plus log b changes into log a into b. If log a into b changes into log a plus log b, then log a plus log b can change into log a into b as well. So it will become log n to the power 3 upon 2 into n to the power 2 upon 3 is equal to log of 10. Now both sides, it is a single term of log. It is a single term of log. We can remove log from both the sides. It will become m to the power 3 upon 2 into n to the power 2 upon 3 is equal to 10. The question is I want answer m to the power 9. M to the power 9. So that means I want 3 here. I want 3 here. 3 3s are 9, but there is a 2 here. So if I raise it to the power 6, suppose I raise it to the power 6, n of 3 by 2 into n 2 by 3 to the power 6, then I'll raise 10 also to the power 6. On both sides I've raised to the power 6. Why have I raised to the power 6? You will see just now. M to the power 3 by 2 into 6 into n to the power 2 by 3 into 6 is equal to 10 to the power 6. 2 3s are 6, 3 2s are 6. It will become m to the power 9 and it will become n to the power 4. What did I want? M to the power 9, n to the power 4. So by raising to the power 6, I was able to obtain m to the power 9 and n to the power 4 is equal to 10 to the power 6. He wanted the value of this. So m to the power 9 and n to the power 4 is equal to 10 to the power 6. So we have been able to solve this. 3 log under root m plus 2 log n cube root minus 1 is equal to 0. In place of minus 1 I have replaced log 10 because there is no base given. When there is no base given, that means we assume that it is common logarithm. That means base 10. So log m to the power 3 upon 2 plus log n to the power 2 upon 3 is equal to log 10. Log a plus log b will become log a into b. M to the power 3 by 2 into n to the power 2 upon 3 is equal to log 10. We'll remove log from both the sides because this side also one term of log is there, there is also one term of log on this side. So we remove the logarithm from both the sides. M to the power 3 by 2 into n to the power 2 by 3 is equal to 10. So and now we are raising it to the power 6 because I want m to the power 9. Somehow 3 by 2 has to be converted into 9. And 2 by 3 has to be converted into 4. So we raise it to the power 6 because 2 3s are 6, 3 3s are 9, 3 2s are 6, 2 2s are 4, and 10 to the power 6. So we got m to the power 9 into n to the power 4 is equal to 10 to the power 6. Now let us see question number 2. Here it says simplify like it is log 8 to the base 3 upon log 16 to the base 9 and log 10 to the base 4. Everywhere bases are different. Everywhere bases are different. We have told you how to convert the bases, how to convert the bases. Log 8 can be written as log 8 upon log 3 and both bases 10. I am changing to common logarithm. Log 8 has been written, log 8 to the base 3 has been written as log 8 to the base 10, log 3 to the upon log 3 to the base 10. Upon, I will change log 16 to the base 9 also. Log 16 to the base 10 and log 9 to the base 10. Similarly, this will be log 10 to the base 10 upon log 4 to the base 10. Now bring this denominator up. It will become log 8 to the base 10 into log 9 to the base 10 into log 4 to the base 10. And in the denominator, I'll get log 3 to the base 10 into log 16 to the base 10 into log 10 to the base 10. We've changed every base to the base 10 by using the formula for changing the bases. If you remember, log a to the base b would have been written as log a to the base 10 and log b to the base 10. That is the principle we have used here. We have taught you how to change the bases. Now let us see what happens in this. Log 2 to the power 3. I am not writing the base 10 because base 10 is common everywhere. Log 3 to the power 2 and log 2 to the power 2 upon log 3, log 2 to the power 4 and log, this is 1. Log 10 to the base 10 is 1. So it will become 3 log 2. The power will come in the beginning. 3 log 2 into 2 log 3 into 2 log 2 upon log 3 into 4 log 2. Log 2 will cancel, log 3 will cancel. So what will be left? 3 into 2, 6, 6 to the 12, 12 log 2, 12 log 2 upon 4. It will become 4 3s are 12. So answer will be 3 log 2. Answer will be 3 log 2. It can be written also log 2 to the power 3, that is log 8. Can be also written like this. So what we did was, we changed all the bases. Log 8 to the base 3 means log 8 to the base 10, log 3 to the base 10. Similarly, everything was followed and we brought them to the most simplified form, where we could write 8 as 2 to the power 3, 9 as 2 to the power 3 to the power 2, 4 as 2 to the power 2, 3 is a prime number, 16 we wrote 2 to the power 4, log 12, 10 to the base 10 is 1. Using those principles, we got the final answer. Now let us see question number 3. Let's see question number 3. That is log a upon b, a to the base b, log b to the base c, log c to the base a. All are multiplied. Let's change the bases. Let's change the bases. It will be log a, suppose, to the base 10 and log b to the base 10. I'm changing to common logarithm. Log b to the base 10, log c to the base 10, into log c to the base 10 and log a to the base 10. Let us see what we can cancel. Log b here, log b here, log c here, log c here, log a here, log here. You get 1 is the answer. You get 1 is the answer, not 0. Some of you may write 0 as the answer. No, 0 answer comes when we add or subtract. While dividing answer will come if everything cancel. It will never be 0. Please remember that. We will never be able to get the 0 as answer. Now let us see question number 4. Question number 4 is root x to the power 4 log a to the base x. It is equal to y. I have to calculate the value of this. I have assumed it to be equal to y. This means x to the power half into 4 log a to the base x is equal to y. That means 2 to 4. X to the power 2 log a to the base x is equal to y. Now what I am going to do is I am going to take log of both the sides. Log of x to the power 2 log a to the base x is equal to log y. This power should come in the beginning as multiple by the power law. We can always bring the power as the multiple or take the multiple as power. So I'll bring this here. 2 log a to the base x into log x is equal to log y. Now it is log a to the base x. Let me change the base log. I can write it as log a upon log x to any base. If nothing, no base is given, that means common logarithm is there. So log a upon log x into log x is equal to log of y. Log x will cancel. What you get is log a to the power 2. This 2 will go up. Is equal to log y. Now we will remove the log. As we had taken the log, we can remove the log also. So a square is equal to y. This is the value of this expression. This is the value of this expression. Y is equal to this. A square is the value of this expression. So changing of the bases is very important and you must understand it. Now let us see question number 5. Let's see question number 5. Question number 5 is log 2 base, then again in the bracket log base 2, and in another bracket log 16 to the base 2. Brackets are closed. Now we'll start from the innermost bracket because that is the place we can start. We can't start from here, we can't think like that. We always start from the innermost bracket, like it will be log of 2, log of 2 base, log, here it will be 2 to the power 4. Because 2 to the power 4 is 16, 2 to the power 4 is 16, so 16, and I will write this as log 2, log 2, it is base 2, and it is 4 log 2 to the base 2. You know very well that any number to its own base is 1 unit. Log 2 to the base 2 is 1, log 10 to the base 10 is 1. Like I am saying, log 2 to the base 2 is 1, because 2 to the power 1 will be 2 if you change it to index form. So it will become log base 2, log base 2, and inside it will be left 4. Why? Because log 2 to the base 2 has become 1. So log 4 to the base 2. Now again what will happen is log base 2, log 2, and I'll write it as 2 to the power 2 again. I'll write 2 to the power 2 again, 4. So again I'll bring the 2 in beginning. In start, 2 log 2 to the base 2. Again this log 2 to the base 2 will become 1. It will become 1. It will remain log 2 to the base 2, and when it remains log 2 to the base 2, again it is going to be 1. So your answer will be 1. Of all this, your answer is 1. Now let us see the last question in this, 6th. To the power minus 1 upon 2 log 9 to the base 3. Again I will assume it to be y, and finally we have to calculate the value of y. So again I am going to take the log of both the sides, log 3 to the power minus 1 upon 2 log 9 to the base 3 is equal to log of y. Now this is the power which will come in the beginning. It will become minus half log 9 to the base 3 and into log 3. Because log 3 is here also, is equal to log of y. It will become minus 1 upon 2. Let's change the power bases. Log 9 upon log 3 into log 3 is equal to log y. Log 3 and log 3 will again cancel here. It will become log 9 to the power minus 1 upon 2 is equal to log of y. I have taken minus 1 upon 2 on top. So when we remove the log, 9 to the power minus 1 upon 2 will be y, or minus 1 upon 2. So it is 3 to the power 2 to the power minus 1 upon 2. So 3 to the power minus 1 is 1 upon 3. The value of y is 1 upon 3. Now let's look for further into logarithm questions, like question number 7. Log a upon b minus c, log a upon b minus c is equal to log b upon a minus c, c minus a is equal to log c upon a minus b. Whenever 3 or more ratios are given, they are always going to be equal to a constant. Let us assume this is equal to constant k. Whenever the ratios are given in mathematics equal, they are going to be equal to a constant and you can assume any constant. I am assuming the constant k. So log A will be equal to k into b minus c. Log B will become equal to k into c minus a, and log C will become equal to k into a minus b. Now log A, I'll take one example. Log A is equal to k into b minus c. I multiply both sides with a. A log A will be equal to ak into b minus c. Similarly, if you take b multiplied with b, b log b will be equal to b into k into c minus a, plus similarly c log c will be equal to ck a minus b. Let us add all of them. A log A plus b log b plus c log c will be equal to what? It will be equal to ak b minus c plus bk c minus a plus ck a minus b. When you open all this, it will cancel, every term will cancel with each other. They are in order. AK, A, B minus C, B, C minus A, C, A minus B, and K is a common. So they will be equal to 0. They are in cyclic order, they will cancel with each other. So it will become log A to the power A plus log B to the power B plus log C to the power C is equal to 0. And 0 is what? Log 1. 0 is log 1. Log 1 to any basis, 0. Log 1 to any basis, 0. So log A to the power A, log B to the power B, because we have to prove A to the power A, B to the power B, C to the power C is equal to 1. So what we are doing is log A to the power A, log B to the power B, log C to the power C is equal to 0 is equal to log 1. Now log A plus log B plus log C multiplied. They will be multiplied. A to the power A, B to the power B, C to the power C is equal to log of 1. Now both sides we can remove log. What will we get? A to the power A, B to the power B, C to the power C is equal to 1. That is what we have to prove. This is exactly what you have to prove. We are given log A upon B minus C is equal to log B upon C minus A is equal to log C upon A minus B is equal to K. And we had to prove that A to the power A, B to the power B, C to the power C is equal to 1. What we did was we equated all of these ratios equal to a constant K. And we said log A will be K into B minus C, log B will be K into C minus A, and log C will be K into A minus B. And then we added all of them. We multiplied it by A because we wanted A to the power A log A, AK, B minus C. This we multiplied with B log B, BK, C minus A. This we multiplied with C log C is equal to CK into A minus B. And then we got, on addition, A log A plus B log B plus C log C. And this is in cyclic order, as I said. If you take common K common, if you take K common, it will be left A into B minus C plus B into C minus A and plus C into A minus B. You can solve it yourself and see that will cut, everything will cancel. K is common, AB minus AC. Let's do it. Plus BC minus BA plus CA minus CB and C AB minus AB, AC minus AC and plus AC, BC minus BC is 0. So that term becomes 0. K into 0 will become 0 and 0 is log 1. 0 is log 1. So log a to the power a plus log b to the power b plus log c to the power c is equal to 0 is equal to log 1. And then we take away the log from both the sides. We get a to the power a into b to the power b into c to the power c is equal to 1. Now let us see question number 8. What are we doing in this question? It is 1 upon log n to the base a plus 1 upon log n to the base b is equal to 2 upon log n to the base b. It is a, b, and c it is here. It is c here, and it is b here. Then he wants you to prove b square is equal to ac. You have to prove b square is equal to ac. Now let's see what do we do. Change the log basis. Log n upon log a plus log n upon log c 2 upon log n upon log b. Take it up. It will become log a upon log n plus log c upon log n is equal to 2 log b upon log n. Now again we will write in the form of the bases. Log a upon log n can be written as log a to the base n plus log c to the base n is equal to 2 log b to the base n. Everywhere the base is the same now. Base is n here, base is n here, base is n here. Here base was a, here base was c, here base was b. With this process I have been able to change the base, because if you are able to change the base, then you can multiply this. Log a plus log c will become log a into c to the base n. This can only happen when the bases are same. I could not have done the same process here. I have to change the base is equal to log b to the power base to the power 2. Now here also log has got base n, here log has got base n. So we can see AC will be equal to b square, and that is what exactly we had to prove. AC is equal to b square. AC is equal to b square we had to prove, so we are able to do that. Now next question number 9. You have to go through these questions. These are little typical on its kind. Generally, you won't come across these questions, but even then you should understand, and if you come across, you should be able to solve them. Like question number 9 is, he has given you a is equal to log yz to the base x, b is log zx to the base y, and c is log xy to the base z. And he wants to prove that 1 upon 1 plus a plus 1 upon 1 plus b plus 1 upon 1 plus c should be equal to 1. Let us see first of all. 1 plus 1 upon a. Let us see this only. It will be 1 upon 1 plus log yz upon x. Okay. Now I can write this as 1 upon log x to the base x plus log yz to the base x. Any 1 is always the number taken to its base. log x to the base x, log 2 to the base 2, log 10 to the base 10, log 1 to the base 10, log 3 to the base 3, all will be equal to 1. So instead of 1 I have written log x to the base x plus log yz to the base x, whatever is the base here I have converted. It will become what? When base is the same, they get multiplied. It will get log xyz to the base x. Is that clear? I can write this as 1 upon log xyz upon log x. Or I can write this as log x upon log xyz. Or it can be written as log x to the base xyz. Change the base to xyz. Similarly, 1 upon 1 plus b will be 1 upon 1 plus log zx to the base y. So I can write it as log y to the base y. I can write this as log y to the base y plus log zx to the base y. It will become log xyz to the base y, or it could be written as log y upon to the base xyz in the same fashion as we have done it here. And 1 upon 1 plus c, 1 upon 1 plus c will become what? Log z to the power xyz. What has happened is we have converted for everything the base same x, y, z. So 1 upon 1 plus a is log x, x base x, y, z, log x base x, y, z plus 1 upon b will be log y upon x, y, z plus log z to the base x, y, z is equal to 1. We have to prove it is equal to 1. So it will become what? Log x, log y, log z multiplied. It will become log x, y, z to the base x, y, z. Why? Log x into y into z, and the bases were same, that is why they could be multiplied. So log x, y, z to the base x, y, z will be what? 1. Any number to its own base is equal to 1. Any number to its own base is equal to 1. So we got this. Now let us do question number 10. Question number 10 is find x if log x to the base 10 minus log 2x minus 1 to the base 10 is equal to 1. 1 I'll write is log 10 to the base 10. Why? Because I will need to remove the log. For that I should have log both the sides. So 1 can be log 10 to the base 10. Why 10 to the base 10? Why not 2 to the base 2? Because here the bases are 10, so I'll keep the base 10. Log A minus log B. Log A minus log B means log A upon B. 2x minus 1 to the base 10 is equal to log 10 to the base 10. Both sides, bases are 10. Both sides, this is one logarithm, this is one logarithm. They can be equated. So x upon 2x minus 1 is equal to 10, or x will be equal to 10 into 2x minus 1, or x will be 20x minus 10, or x minus 20x is equal to minus 10, minus 19x is equal to minus 10, x will be 10 upon 19. That is the value of x. He wanted you to calculate the value of x. Question number 11 is 3 to the power log x minus 2 to the power log x is equal to 2 to the power log 2x plus 1 and minus log 3 logs 3 to the power log 3 to the power log 2x minus 1. So we are writing 3 to the power log x minus 2 to the power log x is equal to 2 to the power log 2x 2 to the power 1 minus 3 to the power log 2x and 3 to the power minus 1. Okay. Now let us bring 2's together, 2 side, and this log together on the other side. 3 to the power log x plus 3 to the power log 2x, and this is 3 to the power minus 1 is equal to 2 to the power log 2x, and 2 is here, plus 2 to the power, it is log 2x, and this is 2 to the power log x. Now question was, just a moment, let me see the question once more. 3 log x
You want to restart?
No, it's alright. Not 2x, x minus 1. It is not log 2x, it is log x here also. It is log x here also. X minus 1. So it is log x. It is log x. It's alright. Now we'll take 3 to the power log x common. 3 to the power log x common. It will be 1 plus 1 upon 3. Because 3 to the power minus 1 is there, and it will become here log x is common, 2 plus 1. So it will become 3 to the power log x, and it will be 4 upon 3 is equal to log x, and this is 3. Okay, now let us write 3 to the power log x upon log x. We brought log x to the side. It is equal to 3 upon 4 upon 3. So it will go up. It will become 9 upon 4. Okay. So 3 to the power log x. Okay, 3 log x. 2 log x it is. 2 log x, 2 log x, 2 log x. So it will become 3 upon 2 to the power log x is equal to 3 upon 2 to the power 2. 3 log x upon 2 to the power log x is equal to this. So both sides, the bases are same, so powers will be equated. That is, log x will be equal to 2. So x will be how much? 100. Suppose x to the here any power y, base y is there. So what is there? If the base is 2, if the base is, because there is no base was here, so 10 to the power. So x will be 10 to the power 2, that is 100. So x is 100. X is 100. Okay, let's see the next question now. The 12th one. In the 12th question, it is log x to the base 2 plus log x to the base 4 plus log 16 to the base x to the base 16 is equal to 21.4. All the bases are different here, so let us do this. Log x upon log 2. I can do that. Log x upon log 2, change the base, plus log x upon log 4, or I can do log x upon log 16 equal to 21.4. Now what I can do is I can write it as log 2 upon log x plus 1 upon log 4 upon log x plus 1 upon log 16 upon log x equal to 21 upon 4. Now it will become log 2 to the base x, 1 upon log x to the base 2 plus 1 upon log 2 to the base x, log 4 to the base x plus log 1 upon log 16 to the base x is equal to 21 upon 4. It has become like this. Now after this, here it should be log 2 to the base. Now it should become log 2 to the base x. 2 to the base x. It should become log 4 to the base x. It should become log 16 to the base x. So 1 upon log 2 to the base x plus 1 upon log 2 log 2 to the base x plus 1 upon log 4 log 2 to the base x is equal to 21 upon 4. It is log 2 to the base x. 4 can be written as 2 to the power 2, so 2 will come in the beginning. 2 log 2 to the base x. Log 16 means 2 to the power 4, so 4 comes in the beginning. Now log 2, log 2, log 2 is common. 1 upon log 2 is common to the base x. And what is left? 1 upon, this is 1 plus 1 upon 2 plus 1 upon 4 is equal to 21 upon 4. So 1 upon log 2 to the base x, it is how much? If I take LCM, 4 plus 2 plus 1 will be equal to 21 upon 4. So it will become how much? I have to calculate the value of x. Log 1 upon log 2 to the base x into 4 to 6 plus 1, 7 upon 4 will be equal to 21 upon 4. 21 upon 4. So log 2 to the base x will become how much? If I take it up, 7 upon 4 into 4 upon 21. So 4, 7 3 is 21. So log 2 to the base x will become 1 upon 3. Log 2 to the base x will become 1 upon 3, or if I change it to the index form, it will become like this. X to the power 1 upon 3 is 2, or x will be equal to 2 to the power 3, x will be equal to 8. The value of x will come out to be 8. That's it.